Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Innovative Fire Protection Solutions. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our customs, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders, past, present and emerging. Before we get started, I would like to acknowledge that today's webinar has been hosted with Engineers Australia's industry partner, Hilti. Hilti engineers and technical specialists have lived at the forefront of construction. They've helped make job sites safer, more productive and more advanced. Hilti Engineering Solutions have set the standards for excellence, offering a range of technical solutions, services and software to help you take control of your project from the initial design brief through conceptual detailing to final product selection and installation. Today we'll hear from 3 speakers followed by our live audience Q&A session. And I would encourage you to send your questions through to our speakers via the YouTube chat box during our presentations today. I'd now like to welcome our first speaker, Hani Adnan. Hani is a qualified mechanical engineer, fire protection specialist with more than 17 years of experience in the construction industry in areas related to passive fire stopping code developments, installations and inspections methods. Hani is an International Fire Stop Council certified perimeter fire barrier inspection expert, and some of his roles have involved being a fire protection specialist for Hilti Middle East, Turkey, Head of Engineering and Codes and Approvals Manager in Hilti Dubai, where he's contributed to the development of the codes and other industry requirements for passive fire stopping systems in these regions. Please join me in welcoming Hani Adnan.
Hi, my name is Hani Adnan. I'm the Codes and Approval Manager at Hilti Australia for fire protection, and actually I'll be the first speaker in today's webinar. We will highlight some general principles of passive fire stopping systems, including types, applications, testing standards, and some key milestones in code developments over the past years, but until today. First, why do we need to seal an opening? And maybe it's a bit unusual to start a fire stopping presentation with this picture. Here you can see a small sailing boat, and on the right of it, a big turbine ship. And if I have to choose between both, for the matter of reaching faster or going farther, I might consider the second option here. But what if there are some small openings in the ship deck? Here, considering the hazard associated with these openings, as you know, the sea will begin to flow into the ship, causing a high safety risk. This will surely affect my choices, as safety comes always first and before any other objectives. And absolutely, nobody wants to end up in a sinking boat. Now, same in relation to building construction. Openings in walls and the floors has another set of hazards associated with them, such as the spread of fire, the spread of smoke, general stability, and so on. However, the objective remains the same: saving lives, protecting assets, and improving structural performance. Now, passive fire stopping systems highly depends on the compartmentation designs. The compartmentation, or what sometimes people call it fire zones, is a globally applied principle for fire safety. It's well covered as well in the National Construction Code 2011 under the Part C2, where every building will be constructed in a such way that in the event of the fire, flames, smoke are limited from spreading within the building. This restriction achieved by dividing the building into separate compartmentation or separate fire zones by a fire resistance walls, and this is what usually called vertical barrier or vertical compartmentations, or dividing the building by a fire rated floor which usually called horizontal compartmentations or horizontal barriers, and could be a combination of both, so vertical and horizontal compartmentations. This way of dividing the building into smaller protected zones will help containing the fire in the area of origin, and that will help protecting the escape roads like corridors, stairs, and other designated fire exits. It also provides a sufficient structural stability and, most importantly, allow enough time to evacuate the building. Now, as you're all aware, services, utilities, construction joints sometimes penetrates a fire-rated walls or sometimes penetrate as well a fire-rated floors. These openings are weak points that can affect the overall performance of the fire compartmentation if it is not sealed. And passive fire stopping materials play a big role here to close these penetrations and to maintain the original integrity of the designed fire compartmentations. Now, passive fire stopping can be divided into three different categories. The first one is a true penetration, and basically it's an opening in a fire-rated assembly, such as a fire-rated floor or wall, where services passing or construction joint occur. Sorry, it's just about the services, when services passes, and where the integrity of the wall or floor needs to be maintained. Actually, the construction joint is covered in the second type, which called construction joint, and it's basically any joint, whether static or dynamic, between two fire-rated elements. For example, joints between floor-to-floor configuration or wall-to-wall configuration, or the joints between the floor and the head of the wall configurations. Now, these first two, service penetrations and construction joints, are well covered in the NCC under the deemed to satisfy provisions C315 and C316. The third category is the perimeter joints, and sometimes people call curtain wall joints as well. And again, it's any joint, whether static or dynamic, but this time it's between a fire-rated floor assembly and non-rated exterior wall assembly. This last one, unfortunately, we don't have yet any deemed to satisfy provision for it in the local building code. Neither a local testing standard procedure to test this kind of application, although we have an international testing standards where this application can simply test it. For example, American standard ASTM 2307 or European standard EN 1364 Part 3 or Part 4. However, what I want to highlight with regards to the last type of passive fire stopping, in our NCC, in the National Construction Code, CP2, spread of fire, state that a building must have elements which will be, to a degree necessary, avoid the spread of fire between buildings and in a building. And this, in our opinion, cover this application as well, especially in a project where the floor required to have a fire resistance level. This application, to some extent, may be considered as a kind of extension of the slab. Now, it's also important to highlight or define the fire resistance level. And fire resistance level, FRL, as defined in the National Construction Code, is grading periods in minutes determined in accordance with Schedule 5. We're going to cover Schedule 5 later on, for the following criteria: structural adequacy, integrity, and insulation. Structural adequacy means the ability to maintain stability of the load-bearing capacity when we do the fire test as determined by the testing standards. Integrity means the ability to resist the passage of flames and hot gases specified in the testing standards. And finally, insulation means the ability to maintain a temperature on the surface not exposed to the furnace. So the temperature on the other side of the fire should be maintained below a certain limit specified in the testing standards. Now, with regards to passive fire stopping systems, it doesn't require to have structural adequacy rating, as it's not considered a load-bearing element. Therefore, it shall have the second and third gradings, integrity and insulation rating. A fire test. Basically, fire test is the way of determining whether the fire protection product meet a minimum performance criteria as set out in the building code or other applicable legislations, and must be conducted in laboratories holding national accreditation for testing the same type of application. And for example, the accreditation body here in Australia is NATA. Here in this slide, I tried to list some of the international testing standards for passive fire stopping systems only, and some of their variations and requirements. And as you see here, for example, the oven pressure, the pressure of the oven when you do the fire test can be varied from standards to other, such as 2.5 Pascal only in the American standards, up to 50 Pascal in the Canadian ones. Also, additional safety measure is mandatory in some standards. We'll give you an example here, the American standards. We pick anyone, ASM E814, for example, which is equivalent to AS 1530 Part 4. This is for through penetrations as well. It's required what we called a hot stream test by applying a higher pressurized water on the tested specimens following to the fire test, following to the refire test, to measure the level of the impact resistance of that burn sample, which make it really hard to pass this standard actually in general. Just to give you an example, some product we see it a lot. We see a lot of those kind of products maybe in Europe and in Australia, like a coated board, which is a kind of rock wool mineral board with some fire protection coating materials on. As I said, we see many of them maybe in Europe and Australia, but not in the States, and simply because they cannot pass the hot stream test. But other thing I want to highlight over here is also there are other standards that has many similar requirements. If we pick, for example, the Australian standard and European standards, so the AS 1530 Part 4 with the EN 1366 Part 3, there are similar in many aspects if we consider, for example, the oven pressure, the non-requirement, for example, for the hot stream test. Both they have the defined field of applications criteria, and also both, most importantly, follow the same what we call time temperature curve. So, which is basically set the regime on how increasing the temperatures happen inside the furnace. And both follow the same ISO standards. However, also there are some minor difference between the two standards in terms of some configuration of some applications. Finally, when it's coming to the testing standards is just one element of the compliances. The other important elements are the correct design on the project level and how it's matching the tested systems, also the right installation methods, and finally product conformity to ensure that what's being supplied to the end user can perform in the same manner to what's being tested in the lab. In Australia, the first important testing standard for passive fire stopping systems is the AS 1530 Part 4 method of fire test on building materials. The scope of this standard is to provide the way of determining the fire resistance level for different building elements, including passive fire stopping system, in order to provide a uniform set of heating condition and testing procedure for the stakeholders. And the way of the testing is by exposing the specimens to a heat under controlled conditions in a furnace. The elapsed times at which various failures cure are recorded, and then the fire resistance level of the testing building elements can be reported. This is the first standard. Now, the second standard, or the second important standard, is the AS 472 Part 1, that sets out the minimum requirement of the constructions, installations, and application of fire resistance tests, specifically for service penetrations and control joints. This standard must always use in conjunction with the previous one, with the AS15 3rd Part 4. So basically, AS15 3rd Part 4 sets how to do the fire test, and AS472 how to utilize the results and applies them. Also, the 472 provide the basis of permissible variation and the assessment requirements. And maybe in a short term, AS472 Part 1 provides the field of application rules for what being tested to AS15 3rd Part 4. Finally, those standards, for example, AS472 Part 1 standard has another important informative section that we should not overlook, such as, for example, Appendix C, physical performance of control joint seal, which provide more details on other additional requirements beyond the fire resistance testing for those sealants. And this appendix will be covered later on in today's webinar. Now, fire stopping current provisions and the current NCC are a result of many years of progressive development in this field. In the 70s, building code development in the United States, Canada, Australia, Germany began reflecting interest in fire protection in general by providing some basic design requirements related to the compartmentation rules, also some recommendations of the usage of non-compressible materials, some special recommendation such as the use of a protected shaft to pass compressible surfaces like cables, wires, and so on. The Australian Uniform Building Code was based on the New South Wales Local Government Acts, and this caused a high amount of variation from the original model, with many states and territories changing the provisions of the model to meet their local needs and their local legislation. So there was a clear need for nationally harmonized building construction regulation, which finally achieved by the releasing of the first edition of the Building Code of Australia, BCA 1988, which been further refined in the second edition, BCA 1990. This code has improved in many aspects, such as the compartmentation, building classifications rules, and so on. And also, by the way, in this code, we had the burn of the Part C, which we still have in our today code as well, for the fire resistance of building elements, with a specific class for opening for service installations in C314 and installation deemed to satisfy solutions at Part C315. Now, I just want to highlight that at that time, one of the main challenges for passive fire stopping application was the variation between what's being tested and the site condition configuration at the project. And the reason why the Australian standard AS472 that we talked about it earlier, which will provide the field of application rules. For example, you test a certain configuration or size of cables, then apply that test result to other types or sizes if applicable. This is standard, the 472, published only in 1992. And at that time, it was really hard or even impossible for manufacturer to test each single parameter and configuration in a job site to AS15 3rd Part 4. So what's happened, that left a big room for individuals' opinions via sort of judgments and opinion letters to confirm these kind of variations. However, these challenges sorted out in the following editions of the BCA and the National Construction Code NCCs by referring to AS472 Part 1 directly. Moving forward, we had in 1996, the BCA 1996 as the first performance-based code in Australia. This code set the objective and the performance requirement that must meet. These performance requirements, by the way, exist in our current NCC. I'm talking here about the NCC 2019 as well. PCA 1996 has included a performance requirement, CP8, related to both surface penetrations and construction joints. It stated that any building element provided to resist the spread of fire must be protected to the degree necessary so an adequate level of performance is maintained when openings, penetrations, and construction joints occur. And by the way, we still have the exact same performance requirement with no change in our NCC 2019. Now, moving forward, before 2011, the Plumbing Code of Australia, or the plumbing regulation in Australia in general, been developed in alignment with the state and territory water and sewerage authorities. And most regulations were based on British standards and requirements. Then in 2011, both the Plumbing Code and the Building Code came in one single code, which is the NCC 2011, with the 3 volumes. Volume 1, multi-residential building and public buildings, and that basically highly relevant to passive fire stopping systems, and Volume 2 for small and single dwelling and non-habitable building. And finally, Volume 3 applies to plumbing and drainage for all types of building. Now, if we look on the National Construction Code today, I'm talking about the NCC 2011, in comparison to the first release version of the PCA, it had a major improvement from all aspects with regards to the regulations of passive fire stopping systems. It also has an improvement in terms of the accepted evidence of its suitability and the assessment methods. And by the way, I'm not going to cover this now, talking about evidence of suitability and assessment method, because it will be part of the, it will be in other parts of today's webinar. But what I wanted to do actually to highlight this extract from a deemed to satisfy provision, TTS C315, opening for service penetrations, A, tested systems, which has clearly defined the field of applications, compliances requirements, and the reference standards. It refers primarily to AS 1530 Part 4 and AS 472 Part 1. This TTS helped manufacturer, designers, and certifier to refer to a comprehensive document to maintain a code compliance solutions while providing a design or even reviewing a passive fire stopping proposals. This NCC includes as well a deemed to satisfy provisions for ventilated and damper systems, and also a specification DTS path for passive fire stopping system, which basically being carried out or forward from the previous Australian codes, and to provide more flexibility or more choices for compliances path. But it is finally, I really want to say thanks to the Schedule 5 in the NCC, which set out the procedure for determining the fire resistance level of building elements and help reducing judgments and opinions in this field and moving more towards testing and assessment approach, where basically a building element meets the requirement of this schedule if it is identical with a prototype that has been submitted to the standard fire test or an equivalent or more severe testing standards. And the system must be confirmed in a report from an accredited testing laboratory. If the fire tests differ in minor degree from the prototype tested specified here, then the fire resistance level still need to be confirmed by accredited testing laboratory. And as we said earlier, such a kind of allowable permissible variation rules, we can find it in AS 472 Part 1. Dear all, what being presented in the previous slides are just some of the key elements and key milestones, and for sure we didn't cover the entire reform in the passive fire stopping regulations. A lot of great work happened in the past decades, and for sure there are still need for more development and enforcement in coming years, especially with regards to designs, the installations, for the conformity and third-party approach. But only one thing didn't change and we're not going to change over the years, and that is the objective of saving lives, protecting assets, improving building performance throughout a balanced fire protection approach, utilizing the different types of the fire protection measures in order to enhance the fire safety level. Here I have reached to the end of my part. I hope you enjoyed it, and I will be very happy to clarify further these topics during the Q&A session. Thank you.
Thank you, Hani, for your insights. I'd now like to welcome our second speaker, Wang. Dom is a qualified structural engineer. Some of his roles have involved being the firestop testing engineer in charge of local firestop tests and assessments, consulting engineer on project levels on relevant Hilti engineering solutions, including passive firestop to a wide range of project types, where he has developed a good understanding of the firestop products, product development, and solutions in the local market. Please join me in welcoming Dom Wang.
Thanks for your introduction. This is Dom. I'm going to talk about product and product development. Just some history about passive fire stopping product. In 1960, the first known fire stop product, multi-cable transit, was invented. The product is then being used at the Navy compact ships. Then we saw more fire stop products being developed and used at some mission-critical facilities, such as nuclear and power plants. In 1980s, increasing demands resulted from major changes in building code, which allowed plumbing and electrical services to be routed through the wall and the floors other than the riser shaft. The original fire-stopping products were silicon sealant and fire-rated mortars. These products has a very limited prevention when it comes to combustible materials and provide no flexibility for re-penetration. Therefore, intumescent materials and fire pillows were developed and introduced. However, they still have the re-entry issues. The third generation of the firestop product is putties, which offer an intumescent property and also the re-entry benefit. In the past 10 years, manufacturers have developed and produced many of the pre-engineered solutions, what we call preformed devices, that provide advantages and additional attributes beside its main objective of achieving the required FRL. For example, on the left, we see more of a traditional practice in dealing with the cable penetrations. Pillows and coated mineral board are usually used here, where preformed devices have been developed for the same application. Comparing to the traditional practice, the engineered preformed solutions are in general provide higher quality of installation, more reliable, easier to inspect, and result in less wastage. The firestop product can contribute beyond fire rating. The new generation of products are developed to bring in additional attributes, which can add in great value to the projects. These projects can be the standard ones as residential and commercial, or more sophisticated ones, for example, healthcare projects and data centers. The local air standard is also calling for additional attributes for firestop products. Appendix C of AS 4072.1 is sometimes overlooked when selecting firestop solution for construction joints. This informative section states that the construction joints need to retain its integrity for attributes relating to other performance functions, including, for example, durability, adhesion, acoustic property, and also very importantly here, what we're going to talk about, movement and cyclic property. The standard provides guidelines on some international standards which cover additional attributes, such as ASTM C719, standard test method for adhesion and cohesion of joint sealant under cyclic movement, and also ISO 11600, building construction, jointing products, classification and requirements for sealant. Also, the same standard also recommended the following. Sealant around the penetration and surfaces shall allow for expected relative movement between the surface and the penetrated element. So here's the list of testing standards for movement. For construction joint under ASTM setting, the movement tests need to be done in accordance with ASTM E1399 and also ASTM C719. It's the standard test method for cyclic movement for architectural joint system. Movement test is mandatory under ASTM setting, and the same movement tested specimen will be then loaded into furnace for the fire test. ASTM E3037-19 has been developed a few years ago for assessing relative movement capacity of through penetration firestop system. The standard is not mandatory, but this is the only available movement test standard for through penetration. I hope to explain the standard a bit further in the next few slides. The standard includes, so what is the standard E3037? The standard includes a standardized bench test, and it is also a system test. The recommended cyclic movement speed is around 50 centimeters per minute. Performance matrix is available, as you see in the slide, and this performance matrix can be used for categorize the system. Maximum movement is specified and recorded during the test, and the test is conducted in 2 axes. So what do we mean by test conducting with 2 axes? This is a picture showing the test setup. We have a movement in the y direction, which is left and right to the page, and also the movement to the z direction, which is perpendicular to the separating element, creating actually the shear strength on the test product. So if we put the coated board system and a preformed firestop block system into a movement test, we will see the block system is more adapted to the movement and more reliable under the following fire test. Due to the fact that the firestop block is intrameson material, it will expand during the fire and close the visible gaps that have been left during the movement test. The gap can be seen quite clearly in the picture. Also, we prepared a quick video to show you the property of intrameson material. So once the fire reached 150 degrees Celsius or 180 degrees Celsius, around 2 minutes under the standard fire curve, the intrameson will start to expand and exert pressure on the combustible plastic pipe. The intrameson will grow and fill the full opening and harden to a more rigid chop, completely blocking the opening, hence achieving the fire stop performance. In addition, if we consider data center and healthcare projects, mineral wool fiber from the coated mineral board is not designed to contribute to the clean room class. We can see that the tests in the lab show the repenetration points risks of exceeding the limit. The second additional attribute we would like to discuss today is the air leakage. It is also called the air rating. The most internationally recognized test standard for air leakage rating for through penetration is Part 6 of UL 1479. The air rating measures the air movement through the fire assembly at the ambient air temperature around 24 degrees Celsius and at an elevated temperature around 204 degrees Celsius. The internal air pressure remains at a constant 74 pascal, and the movement of air that leaks through the firestop system is measured. According to the standard, the air rating should not exceed 5 cubic foot per minute per square foot. The rating less than 1 means a good performance, best performing, where increasing number means a decrease in performance of sealing. Air leakage test is an optional test. However, manufacturer can use this test to demonstrate the product capacity in preventing smoke and air leakage. The L rating can then be used in product specification for healthcare and data center projects, where airflow is very essential. The graph shows a quick air leakage test comparison between a preformed passway device and a different design preformed sleeve device. As you can see, when there's no cable running through the device, both systems have very similar low air leakage rating, less than 1. But when more cables are added to the device, the air rating of the passway device starting to climb, hence a decreased performance in stopping smoke. In some cases, it also well exceeded the threshold of 5 cubic foot per minute. The preformed devices probably need more attention during the product development time and needs to be properly designed and engineered to ensure that the product and the solution is reliable and outperform existing practice. And we also wanted to give our thoughts on the firestop moving forward, as we see some great innovations locally in Australia in the past 10 years in firestop space. And we have better enforcement now on the code compliance. Apart from that, firestop solution can be and should be more reliable. For design, designer could more clearly define the requirement, for example, additional attributes needed on the project, selecting right product and solutions, and conduct more detailed planning. For install, the installation can be carried out by trained and experienced installer, and on the product side, products can be developed to make installation easier and with simpler mechanism. For certification, we already see documentations on digital platform. What's probably going to happen next is how to cross-check with the design detail. All in all, the base here to make our firestop solution more reliable is the product conformity. All right, thank you. That's my part.
Thanks, Dom, for your insights. I'd now like to welcome our third and final speaker for today, Matthew Wright. Matthew Wright is UL's Built Environmental Manager for Australasia, a position created by UL to spearhead development of UL service offerings tailored to Australia and New Zealand. As an influential industry advocate, Matthew has achieved meaningful changes in legislation, codes and standards, including strategic generational change to the fire safety strategies of the National Construction Code, as well as frameworks for practitioner competency. Matthew's current role is focused on championing product safety and certification solutions and providing a conduit to contemporary research, responding to emerging trends and hazards. Building on UL's global reputation of integrity, safety science and thought leadership. Matthew holds a bachelor's degree in building surveying, graduate certificate in performance-based building and fire codes, and a graduate diploma in fire safety and risk engineering. By ministerial appointment, Matthew also served 2 terms as a member on Victoria's Building Appeals Board and was Fire Protection Association Australia's inaugural Building Codes Committee representative for the Australian Building Codes Board. Please join me in welcoming Matthew Wright.
Hi there, thanks for the introduction, Megan. Thank you for joining this session, and thanks to Hilti and Engineers Australia for the opportunity to participate. My name's Matthew Wright, and I'll be presenting about the importance of product conformity. I'll be providing a general overview of global compliance concepts regarding conformity and how these relate to local requirements. UL, if you don't know, is a safety science company, and as a global safety science leader provides the expertise, insights and services necessary to solve critical business challenges. My role at UL is to lead our interests in the built environment for Australia and New Zealand. So global supply chains and a more discerning need for trust is an area where I want to start. Consumers and product procurers have an extensive choice when it comes to product selection, and product manufacturers have multiple avenues available to them in terms of material and component supplies. Global markets can mean that supply chains too are global, but even product produced for a local market can be impacted by complex supply chains. Add to this the need to navigate regulatory requirements that can overlap or be market exclusive, and visibility and trust are key to achieving compliance and maintaining brand integrity. Understanding and control of the supply chain is imperative. These factors can be considered even more important in the ANZ region, where some building products are manufactured locally and exported, but we're predominantly importing product. This image explains the struggle to align stakeholders regarding product knowledge and NCC knowledge. As you can see, the product supply chain phase has good expertise with practitioners regarding the product itself, but less expertise in relation to the targets and expectations of the code. In the construction phase, those ultimately responsible for product selection and approval, there is increasing knowledge about the code, but not necessarily how the product meets these code requirements. Fire safety designers and fire authorities involved in the construction phase should be able to identify the target for product conformity and whether or not this has been achieved. Beyond the construction phase, we'll also demand knowledge about product conformity to maintain operational performance during building occupation. If we get product selection wrong, we risk that in any emergency phase, products may fail and the fire safety strategy for the building might not hold up. However, currently a lack of confidence in this sector has emerged. The complexities associated with the supply chain, as well as regulatory expectations for product conformity, have drawn the attention of governments and industry stakeholders globally. More focus has been applied in recent times to a result of reported product failures or incidents, particularly those associated with safety. Scathing independent reports in the UK and Australia have documented extensively the general lack of confidence in the successful implementation of codes and standards. These reports have highlighted the importance of product conformity as the foundation of safety outcomes, and other measures like good design and the competence of practitioners rely on. If you can't trust the conformity of the product, it's difficult to have confidence in its ability to support the nominated holistic design and safety objectives it is intended for, no matter which other stakeholders are involved. Confidence in product conformity is important for all manufacturers, authorities, and end users. And you'll see on the screen here, there's two reports that I've nominated and a couple of links to those if you haven't seen them already. One's the Hackett report from the UK, and the other is a Shergold-Weir report from Australia. Both are very consistent in relation to their recommendations and the issues that they've observed. And there's a quote here from Peter Shergold and Bronwyn Weir, who are the authors of the Building Confidence Report, otherwise known as the Shergold-Weir report. And they say it's our considered view that the nature and extent of the problems put to us are significant and concerning. They are likely to undermine public trust in the health and safety of buildings if they're not addressed in a comprehensive manner. So there's some pretty strong words in relation to the status of industry at the moment. Excuse me. So here are two other quotes in relation to this from within the local industry. The first is a quote from the Australasian Procurement and Construction Council's Guide to Achieving Compliance for Construction Products, and sums things up well. We're working in a global marketplace. There are many products that we're importing, and the most concerning consequence of construction product failure is its impact on safety. Without doubt, the use of faulty construction puts lives at risk. The second quote is from a Federal Senate inquiry in relation to non-conforming products, and is actually one of the recommendations for the inquiry. And it calls for Building Ministers Forum to expedite its consideration of a mandatory third-party certification scheme for high-risk building products and a national register for these products. We're not quite there yet in relation to that, but there is a lot of work happening in this space across state, territory and federal governments. And there are some quite broad recommendations and discussion papers that have been produced by the Australian Building Codes Board in relation to this, if you care to look for those. So throughout the building life cycle, what practitioners need to know is, one, what the level or extent of product conformity is required for products and the systems made up of multiple products. Two, what the target standard or prescribed requirement is that conformity has been demonstrated against. Three, what methodology has been used to demonstrate conformity and the level of independence applied to implementing this. Four, the validity of any attestation of conformity. When was it issued? Is it still valid? And five, are there any associated limitations with the use of the product? Right now, these questions are difficult to answer consistently for practitioners and require more education and attention. So having outlined the broad issues, let's now shift to talking about why product conformity is the foundation of safety outcomes. Bear with me here while I change the slides. So globally, one of the key focuses of built environment controls is to deliver improved safety outcomes that acknowledge certain measures can reduce or manage safety risks. Legislation can establish punitive or even criminal penalties if certain processes or approvals aren't sought or met. Regulations, codes and standards referenced by legislation typically outline design expectations, practitioner roles and responsibilities and approval requirements. And design, construction and maintenance activities are tasked with implementing the expectations of approved design. Each of these measures works to reduce the risk to acceptable levels. All of these functions call up or are supported by conforming product. None of these measures alone or together can achieve safety objectives without product that stakeholders have confidence will perform as expected. Product certification is a key pillar for rebuilding trust around safety and compliance in buildings. Product certification is not to be confused with project certification or certification of an installation. It's certification of individual products or sometimes a system of multiple products. The definition of product certification here is provided by the international standard ISO IEC 17067, Fundamentals of Product Certification and Guidelines for Product Certification Schemes. So let's just read through the definition. Product certification is the provision of assessment and impartial third-party attestation that fulfilment of specified requirements has been demonstrated, and is an established conformity assessment activity that provides confidence to consumers, regulators, industry and other interested parties that products conform to specified requirements, including, for example, product performance, safety, interoperability and sustainability. The key points here are: 1, impartiality. Product certification is provided by someone without vested interest in the outcomes. 2, specified requirements have been demonstrated. You've hit the target. Typically, these requirements are repeatable measures or product performance benchmarks. 3, delivering confidence. The reason for conducting product certification is to provide confidence to multiple stakeholders that the product conforms to established requirements. Product certification is an internationally recognised process for product conformity assessment that delivers confidence due to the independence of those undertaking the assessment and the very nature of this assessment itself. So product certification provides value to both manufacturers and suppliers, as well as consumers and end users. For manufacturers and suppliers, it can be used to demonstrate to the market that a third party has attested that their product fulfills specified requirements. For consumers and end users, it can be used to design, approve, select, or install products with confidence that they will meet specified requirements. These benefits apply throughout the building life cycle, which attracts multiple practitioners and stakeholder groups from design all the way through to routine service and maintenance. So let's take a look at the current options locally. The first step in determining product acceptance is identifying the driver for conformity. What is the extent of conformity expected? Is the product use governed by legislation or codes? These may prescribe additional requirements with standards. Alternatively, the use of the product may be covered by commercial or voluntary terms alone. It's important to understand this for your specific situation. In this presentation, we're going to focus on the National Construction Code, Building Code of Australia requirements, noting that the Plumbing Code of Australia has different provisions in relation to products. There are currently 6 options in the National Construction Code, Building Code of Australia volumes to demonstrate evidence of suitability for products. In addition to these, there is specific requirements in Schedule 5 for determining the FRL of building elements. These can include testing, assessment against tested product designed to prescribe standards, or a calculation method. So in addition to these 6, for building elements that require an FRL, there are some specific requirements in Schedule 5. I need to stress that. CodeMark is a certification scheme administered by the Australian Building Codes Board, who write the National Construction Code, and is best suited to products subject to performance solutions. A certificate of accreditation is a power that some states and territories have to approve product. It's a legacy from a time prior to the National Construction Code when there were no national technical provisions, and is now rarely used, with only a couple of jurisdictions still applying it. This leaves options 3 to 6 from the slide here, which I'll discuss in more detail. The evidence of suitability options are presented in the National Construction Code as interchangeable. You can use them individually or in combination. This would suggest that they are equal in their level of product assessment. However, this is far from the case. So whilst they might all look the same, they are not, and there has been minimal, if any, education provided to industry on these matters since the National Construction Code, Building Code of Australia, was first introduced in 1990, despite a recent Australian Building Codes Board handbook and guide being published. There's a recent ABCB discussion paper suggesting reform that analyses the current requirements and product certification is promoted. You can still read this discussion paper online through the ABCB website. So let's consider these and compare them. The first that I want to look at is any other form of evidence, or any form of evidence. It's the most flexible and does have some merit, but is extremely subjective and prone to abuse. Part of its reason for existing is to reconcile Australia's World Trade Organisation agreement on reducing technical barriers to trade. A good use of this option would be to accept a sprinkler head, for example, that has been certified by UL in the United States to US standards that are also recognised in Australia. A bad use of this option would be the, quote, note from your mum. It puts enormous pressure on the authority accepting it, but including liability if they cannot demonstrate the reasons for accepting it. The next option is subjective opinion. This is to accept a certificate from a professional engineer or other appropriately qualified person. It isn't product certification as defined internationally by ISO. This option simply increases the threshold of competency in relation to the person providing a certificate. It doesn't necessarily determine a consistent competency threshold, and it doesn't set any consistent methodology for arriving at the decision to issue a certificate. Ultimately, whilst there is room for this option, it is still subjective opinion. A test report from an independently accredited and competent test lab is next. In addition to increasing confidence by application of independent accreditation, it's also likely to result in the use of a standard test methodology, boosting assessment rigor. However, a test report only represents a single point in time, a one-off test on a single sample. A test report alone cannot confirm that the product that turns up on site and is installed will conform as the one tested. Third-party certification includes multiple components that deliver the confidence industry needs. These include independent accreditation of the organisation delivering the scheme and the labs providing evaluation data that's being considered, demonstrating independent competency and capability to make impartial judgments, appropriate scheme rigor to ISO IEC 17067, the use of product marks linking physical product to certification information, publicly searchable directories that link to product certification information, and production surveillance that provides confidence in ongoing conformity of the product. If we compare these options, we can see that the risk of non-conformity increases the further we step away from third-party product certification. Let's look at the components of third-party product certification. I think it's important that we define what we mean by third party when we talk about product certification. For context, let's compare how it relates to first and second party activities. First party is conformity assessment activity performed by the person or organisation that provides the product, effectively self-certification if you like. Second party is conformity assessment activity performed by a person or organisation that has user interest in the product. So this could be someone who has vested interest in the outcome and invests themselves in conducting an assessment on the product that they're purchasing. By contrast, third party is conformity assessment performed by a person or organisation that is independent of the product provider and has no user interest, therefore completely impartial and able to be relied on by multiple other stakeholders. The image presented here outlines the key components of a comprehensive third-party product certification scheme applied independently to determine product conformity. So we'd start by prescribing the prescribed requirements or standard, the target that we're trying to hit in relation to conformity. Tests would be undertaken, reviewed, and an evaluation report prepared and presented. There'd be an initial factory audit of the product to determine the manufacturing process, and then an independent review and decision in relation to whether conformity had been achieved, and a certificate could be granted. Granting the certificate would also allow for products to be marked, linking the physical product back to the certificate, and an online directory so that other stakeholders could access this information. This would be complemented by ongoing production surveillance of the product. As we can see through this assembly of components, a test report is not product certification. Instead, it's a single point in time evaluating a product and evaluating a single sample, a snapshot with no further follow-up. We can also use this diagram to illustrate product certification that goes beyond a single point in time test, but includes only batch testing, not ongoing production surveillance. The full complement of components all the way through to and including production surveillance provides the most confidence in product conformity. Third-party product certification processes can include multiple components, and not all certification schemes are the same in relation to the type, number, and extent of these components. This table is drawn from the standard ISO IEC 17067, in fact Table 1, and presents the types of conformity assessment functions that can be assembled to make up individual schemes. These include selection, how characteristics of the product are determined or evaluated, review, decision-making on certificates, and how attestation of conformity is provided, which could include documentation and license use of product marks. The columns to the right-hand side of the table indicate how the assembly of these different components could result in different scheme types. I'd like to draw your attention to section 6, which I've highlighted here in the red border. This relates to production surveillance and the number of ways it could be undertaken. This includes 1. Testing or inspection of samples from the open market. 2. Testing or inspection of samples from the factory. 3. Assessment of the production, the delivery of the service or the operation of the processes. Or 4. Management system audits combined with random tests or inspections. Note that product certification scheme types 1A and 1B are separated from types 2 to 6 on the basis that they do not include production surveillance activities. Product surveillance is a key hallmark of the more advanced product certification schemes and provides value to product manufacturers and end users alike. It can be provided in a number of formats in order to independently assess the manufacturing process is continuing to produce conforming products. So it could include surveillance of the manufacturing processes or formulation of materials at the point of manufacturing. It frequently includes random selection of raw materials and or finished products for quality checks at specified intervals. It may require audit testing in an independent accredited lab to confirm product performance, and it must be conducted by a recognised provider of such services. Factory product control and auditing must be informed by an ISO accredited provider. This flowchart nicely summarises how the product certification process comprehensively assesses product conformity in accordance with ISO IEC 17000 suite processes. Of particular note is the ongoing feedback loop of factory inspection and product surveillance. So in this example on the flowchart, an applicant will bring their product to the third-party certification provider, in this case UL. The third-party product certification provider would undertake testing and produce an evaluation report, and also an initial factory audit in terms of considering the production manufacturing process, produce a report. Those two pieces of information would be considered for review and a certification decision made. If the product was deemed conforming and successful, a certificate would be issued for that, and the product would be able to be marked and placed on a directory or a listing with that certificate for public viewing of that information. Rather than stopping there, then there is an ongoing feedback loop beyond that initial certification to continue doing production surveillance of the factory over the lifespan of the certification to make sure that it's current and still in place, and that product certified by this process continues to conform. So you can have confidence that the product turning up on site is going to conform as assessed by this process. So next, I'd just like to highlight some advantages of third-party product certification. And these advantages across different stakeholders in the process. So I'm not going to touch on all the detail here, but let's just go through some of them in a high level. For manufacturers, they can independently demonstrate that product conformity is being provided. This is what third-party product certification gives real confidence in, and it helps with their quality management and surveillance of their production processes, and obviously maintaining brand integrity. It can really support trade, import and export activities. And whilst Australia has different options for evidence of suitability, as we discussed earlier, third-party product certification in other regions of the world is actually used as the tool that helps trade between different regions, because it gives so much confidence in the product's conformity. For designers, use of third-party product certification allows more confidence in being able to specify the product type and the conformity expectations in documentation, and that these will actually be achieved and can be sourced through commonly understood language, so that procurers of the product can actually understand what the designer's expectations were. For builders and installers, product certification, if nominated in a design, gives clear expectations and obligations for procurement of product, and when they're being presented with information about product, they can select it with confidence in relation to knowing that it conforms, rather than, as I speak to some builders these days who are fed up with getting different pieces of paper from different people purporting different things. They want some consistency and some confidence that products actually conform. For approval authorities, it gives them peace of mind that the compliance that's required by the code is actually being achieved by the entire design and the products used within that design. And where product conformity and certification schemes have a link to an online database of information, this can also help with digital transparency in relation to the circulation of products and the information within them. From a legislation, codes and standards point of view, certainly distilling the requirements down and being clearer about which products or which type of risk require which types of conformity information would help the industry and also help regulators applying the codes and standards and their enforcement activities. So there is a triple bottom line, though, in relation to the advantages of third-party product certification. We would all be aware of the issues associated with insurance in our industry, and use of third-party product certification can increase confidence of the risk landscape control for insurers. Premiums can be adjusted to reward good practice, and data can be shared with regulators and industry to identify areas for improvement. Third-party product certification also supports investors by increasing confidence in building quality, improved appetite to invest broadly, and stimulating industry and economy with growth with jobs. Ultimately, though, our aim with third-party product certification is safety, increasing confidence that the community safety objectives have been achieved and restoring our reputation and maintaining this for quality and compliance. So the issue here that we have is in relation to needing a change. To improve confidence and empower trust, we need to make changes to how we approach products. This can be distilled into three key areas. Number one, product quality can be driven by raising product conformity expectations, including the rigour of performance assessment and evaluation. Manufacturers should be incentivised to invest in product management processes to maintain product quality and achieve product conformity expectations consistently. Two, our expectations for how product conformity is documented needs to evolve throughout the design and specification phase through procurement, installation and approval. Practitioners should be able to confidently make informed decisions about product conformity and compliant use. Digital connections between the physical product that arrives on site and the certification information that provides conformity is critical. Three, we need to stop the subjective storytelling. High-risk products that are essential to delivering safety objectives should be subject to an even playing field of conformity assessment, not multiple options of varying rigour that can fail to deliver consistent minimum product conformity outcomes. Finally, we need to educate industry stakeholders. Product conformity is the foundation of safety outcomes that we've discussed in this presentation. There is a critical shortfall in the understanding of this process, and other reforms associated with design requirements or practitioner competency cannot have meaningful impact without conforming product. So here's some key takeaways guiding your confidence. You should be asking yourself, what is the product risk in relation to failure and contribution to overall safety? What evidence of conformity has been presented? Is the rigour of this evidence appropriate for the product risk? Does the evidence reference the appropriate legislation, code, standard or contract requirements? Can you verify the independence, competency and capability of the person or body issuing the conformity evidence? How many components providing confidence are associated with a product conformity option? Is production surveillance undertaken to confirm ongoing product conformity? Can you match the product with the documentation of conformity by way of markings or publicly searchable directories? And are there any limitations associated with product installation to achieve compliance? So that's the end of the presentation for me. I hope you've got something out of that, and I wish you well on your journey to determining product conformity. Thank you very much.
Thank you, Matthew, for your insights today. So now's the time when our speakers will come together to take our audience questions. So if you would like to submit a question, please do so via the chat box. And if you could just ensure that you provide your name and who the question is directed for. Now, we did actually receive some questions on registration, so thank you to all those people who sent them through. So we might begin with a couple of those. Now, the first question that we have, it came from Gregory in New South Wales, and he is directing his question to the panel. So his question is, can you provide insights and thoughts on how well the passive fire industry is providing documented, accredited solutions to the industry? Some suppliers have elaborate selection programs which need to be paid for, while others still are reluctant to provide test reports for their products. Should the issuing of test reports be mandated in the National Construction Code? So who wants to kick that one off? Hani, would you like to start our Q&A today?
Thank you, Megan. I would really prefer maybe Matthew as a third-party certification authority to really tackle that one, not from the manufacturer perspective only.
Yeah.
All right, well, Matthew.
That's okay. That's fine. Happy to, Hani. And thanks very much for the question, Greg. It's really a very good one. I think to break down your question in a couple of parts, in terms of how we're providing solutions to the industry from a passive fire protection point of view, I think there's a level of inconsistency there that you've perhaps identified in your question, that you're getting different information from different people, and that doesn't help with the confidence of the different stakeholders in the process. I think most people, most practitioners have a really good objectives in terms of trying to just make sure that they've hit the target. I don't think whilst there's always going to be an element of people who are deliberately trying to do the wrong thing. The majority of the practitioners, and I would assume the majority of them choosing to join this webinar today, would be looking for ways to be professional about processes, and even from that perspective, sometimes frustrated by the different mix of information out there. And certainly, I'm hearing from different sources that there is more scrutiny at the moment in relation to what people are providing, and such as the level of attention that we've received from the UK and our own local building confidence report, as I mentioned in my presentation. So that scrutiny is going up, and there's a more discerning need for trust that is driving lots of the questions. And I guess third-party product certification solutions are coming to market, and they're driven because of that incentive to want to have some more consistency and know that product stands up to scrutiny. So I think you'll see them emerging, and that there are multiple sources providing those options, and we're in the phase of changing in relation to that. I guess I'd like to touch on one point that might provide a good transition to the points that Hani might want to answer about this question. But you made a point in your question about the access to test reports. Well, test reports from a third-party product certification point of view, are fundamental to the decision making. However, they contain a lot of proprietary information on how the product actually performed, and certainly from UL's perspective, we produce those test reports when we've completed the testing, but they're provided to the manufacturers as proprietary information that they can choose to share or not. And that's, of course, different to what would be called a regulatory information report under 1530 Part 4 that you might be familiar with, which is more of a summary of the full detailed test report that provides enough information for people to make informed decisions in relation to compliance. However, we acknowledge that in the industry there's also sometimes going to be people who would like that actual raw test data because they're interested in perhaps doing a performance solution or using a product for other means. if that's the case, then they should speak to the manufacturer about getting access to that information. And I'm sure Hani can share with us now more about how Hilti approaches that.
Yeah, thank you very much, Matthew. This is why I want really to have that starting from a third-party point of view. Now, in terms of compliance, this is basically what you have mentioned, RIR, our regulatory information report, are basically called compliance as evidence for sure, definitely. There's no doubt about that one. When it's coming to the testing report, although maybe it's not publicly available, but it's still it's a document that can be and shall be provided by the manufacturer upon the request of the fire engineers, the installers, and the clients as well, especially when they come across a kind of a full fire engineering reports. So those testing reports are available. It's not being hidden for some commercial enters or so. It is really beyond that, some legal perspective and also some contents that really manufacturers don't actually want to share on a certain public level due to some very technicality measures related to it. However, test report not only available, but it shall be shared upon the request of the fire engineers. Hilti as a manufacturer have been shared many of those test reports whenever being requested upon assigning of some kind of non-disclosure agreement. I hope we have answered this question.
Excellent, thank you. Dom, did you want to add anything, or I'll jump on to the next question?
Yeah, I think like Wahani said, we have been supporting fire engineer and really share our test report. So yeah, I think all good from my side.
Awesome. Well, we have had quite a few live questions come through. There is a little bit of chatter happening at the moment. And Millie raised a question before, and her question is, how does a manufacturer ensure that passive fire protection products are installed correctly? So I might hand that one to Hani.
Yeah, I can take that one. Thank you, Megan. And thank you, Millie, for your question. A really very important question, because at the end of the day, is testing, certification is something, but installing the fire stopping product as per the tested system, this is what can guarantee somehow to achieve the same expected fire resistance level. Now, manufacturers play a big role in terms of supporting a right installation procedure, and that starts not only on the site, but actually prior to the installation of passive fire stopping from the specifications stage by specifying the right compliance product, and also try somehow to provide a full schedule of how those kind of product and system can be installed. Now, manufacturers should and shall provide actually trainings for the installers, for the end users, on how to install these, how to read the parameters and the specification and translate it from a test report to a real site condition scenarios. Those can be also followed by hands-on sessions, and many manufacturers, including the manufacturer that I'm working with, Hilti, we do provide those installations training, followed with kind of a certification of attempts for those who could join this installation programs. And definitely we are always welcoming any kind of let's say, request to support during the installation processes by having those kind of joint work, and give some of feedbacks and recommendation. Definitely this is not considered as an inspection due to the conflicts of interest. Definitely manufacturer can be as well a third-party inspectors, but manufacturers getting the fact that they know more about their product, the parameters related, the limitation as well of their installations method, that would help really to enhance at the end the correct fire stop installation on job sites. So basically the training and support during all stages from the specification to the installation going forward. I hope I've answered this question.
Yeah, just maybe add on this side. I think this is also come back to the first question a little bit. Why I think some manufacturer wanted to present the solution in the report, in the regulatory information report, is to cover more cases, providing more drawing about installation.
and that will definitely help in terms of installation. And another practice I think is really, really good I see on site is we usually see this demo before the actual construction. That will help the subcontractor or installer to really understand how to install.
Maybe just one more thing, Megan, to link it back to what we present today in terms of the new generation of passive fire stopping system, because that help as well to ensure somehow a right installation. The new generation of a preformed device somehow reduces the requirement of very high skilled installers, because those product comes already in a shape preformed to the right thickness of the sealant. So basically, the installer at the end, they don't really to have a lot of interaction of a really high skill in order to install the right thickness, the right backfilling materials. Like if, for example, they require to have a rock wool underneath of fire stop, preformed device as well. It help reduce the interaction and help really to get the right installation much easier in comparison to the traditional solution like sealants and caulking and so. Yeah, Megan.
Ania, if I could kind of continue on with yourself, we did have a question which came through live from David. So big thank you for David for watching today. Now, his question was around at what level of fire exposure incident should the intermittent sealer be replaced?
Okay, so he maybe reflect to what we also present in terms of the intumescent. So for maybe the rest of the audiences, intumescent material, those materials actually subjected to a certain temperature will be expand and then closing the gaps expected when you have some combustible materials passing through, like cables or plastic pipes. So intumescent material in general start swelling at around between 150 to 180 Celsius and reaching its fully expansion ratio between 350 to 400 Celsius before forming into a rigid char and closing the gap. So in my opinion, as far as it's reached to that limit of 150 Celsius or even slightly before, this basically where actually the intumescent material being already subjected to kind of physical change, and accordingly it has to be replaced. So I would say it's around 150 Celsius or slightly before.
Excellent, thank you. Matthew, a couple of questions have come in for yourself from the live audience. The first one came through from Millie again. Can Matthew comment on the state of product certification in Australia currently, particularly in relation to previous issues with Codemark's system?
Yeah, thanks, Megan, and thanks, Millie, for your questions. I think it's interesting that your initials are the same as mine, and you've asked multiple questions, and I'm assured that that you're a real person, and it's not me asking these questions. But I think in relation to the Codemark system, I think it's appropriate for me to let ABCB as the custodians of that scheme comment on it. The only thing I would say that I think is reasonable and publicly available is that yes, there have been some concerns when Codemark certificates were withdrawn, but I guess what the important thing perhaps I can comment on further is to understand that Codemark is third-party product certification, but it's one scheme, and there can be there can be multiple schemes in an industry, and as I presented through my slides. Different certification schemes have different components, and that table from the ISO suite of standards, identifies if you're using this combination of components, this is the kind of level or rigor of your scheme, and that just because you've got third-party product certification doesn't mean it's from one scheme, doesn't mean it's going to be the same level of scrutiny or rigor in the assessment as another scheme. It might still be third-party product certification. But that's why some schemes are promoted over others, and certainly in different regions of the world, third-party product certification is a mandatory requirement for products in the fire protection space, and they're perhaps more used to it than we are in Australia, and have developed those systems and schemes over time. And so they're almost a default go-to acceptance that unless there's third-party product certification that has a certain level of rigor, then you're probably not going to have a market for your product, as the market will refuse to accept it. We're still, I guess, maturing in relation to that in Australia across a range of different products, whether it's fire or outside of fire protection. And the flexibility that's given by the code, as I tried to outline in my presentation with the multiple options, means that, I guess, in some ways it has to be a market-led change in relation to seeing that dynamic move. And there are leading manufacturers who are wanting to see third-party product certification, and that's why I think you'll see more schemes being developed by independent providers in relation to that. And whilst Codemark has had concerns raised against it, ultimately the fact that someone was overlooking that situation and making decisions to remove certificates is in fact an example of the scheme and aspects of it working well to protect consumers and end users in relation to those products. So that's a kind of extra layer of scrutiny perhaps that you receive for products under a third-party certification scheme, that there is that other level of surveillance, which might not be the case if someone was simply issuing a test report or making a subjective opinion. So there's lots of elements to discuss in our industry like that. And Millie, if you're interested in the details and where Australia is at the moment, I'd urge you to go and visit the ABCB's website. I believe their paper on the National Building Product Assurance Framework is still available on that page. If it's not, I'm sure you might be able to contact Engineers Australia and they could source a copy for you. But that documentation is probably the first time for a very long time that someone in government has pulled all the strands and all the different options together and tried to document what the current landscape looks like and made some recommendations to change, which certainly include promoting third-party product certification, as we've talked about today.
Great answer, Matthew. Thank you for that. We're actually running out of time, but I'll try and squeeze a couple more questions in. So hopefully our speakers are all available for us for a little bit longer. The next question came from Voon in South Australia, and I'm going to direct this one to Hani and Dom. Okay, so this will probably be our second last question for the day. And it is how to identify existing fire-stopping materials in a building during inspection.
Yeah, happy to take this one. Thank you, Voon, for asking this very important question. Actually, it's very limited time to answer that one because I might go detailed answer, but let me try just to highlight the most important part when it's coming to inspection is actually the availability of the documentation to what's being installed. Because at the end of the day, what you do with the passive fire stopping system is basically to check and evaluate what's being installed, what's being tested and submitted. And documentations including, for example, compartmentation design, the fire resistance level required, the location of firewalls and fire floors, because this is basically the area where you want to inspect. Also a full schedule of what's being installed, and also a label or tags next to the penetrations or next to the construction joints stating, give some general information about the product installed and the manufacturer and the time of installation. And by the way, this kind of documentations can be found as a recommendation in AS 4072 Part 1 under Appendix B. And actually, we should admit definitely it's really hard to get those documentation when you try to do, for example, your annual inspection on a building. As you know, passive fire stopping as per the Australian standard AS 1851 is recommended to have an yearly inspection. And also it's stated, by the way, the inspector shall inspect representative samples in the non-accessible area. So also accessibility is another issue. So documentations, hard to maintain, yes, but many manufacturers have developed recently some apps and softwares to maintain and keep those documentation over the years and make them available for the inspectors coming forward. This is one of the challenges. The second one, as I said, the accessibility. However, as an inspector, maybe the facility management should always allow a certain kind of access for you to get some random inspection on the area which been concealed. Finally, maybe looking on the existing building, one of the main non-compliance issues basically the modification on the SEM openings, where basically more services being added, especially when it's coming to cables, telecommunications, wires, and so. And one of the features of the preformed devices, for example, it is very flexible in terms of reusing the same penetration again and again. So basically, sleeves, for example, you can just open it, add more services, and then after that, you can close it. This way of avoiding non-compliant from first stage will definitely help to make the inspection work more proactive. So basically, availability of the documentation, and also to some extent the different type of a product can help your inspection to be more productive in comparing to other type of products.
Thanks, Hani. Dom, did you want to add to that one?
I think that's, if we look at existing building, like old buildings, we had a couple inquiries just, of question or want to define the product being used. It is very hard without any documentation. Sometimes we can probably judge if we have casting colors, then probably judge by the type or the color. But if we're talking about sealant, especially acrylic or intumescent type of sealant, that's really hard. Like the product looks very similar, and throughout the time, it's even harder to differentiate.
Thank you, Dom. Look, I think that's actually all the time we have for today. That Q&A went really fast. Please join me in once again thanking our panelists, Hani Adan, Dom Wang, and Matthew Wright, for their time and insight shared at today's session. I would like to thank Engineers Australia's industry partner Hilti for making our webinar possible today. We would appreciate your feedback on the program to help us improve and plan future sessions. So if you could please complete the short feedback form, which is linked in the description box below. Thank you again for joining us, and we hope to see you at our next webinar.